Okay, so we want to find the volume of the solid that results from when we take this function f of x is equal to the square root of x to the fourth plus 1 on the interval x is from 1 to 3, and we're going to spin that around the x-axis. So we're going to take our 2D shape, we're going to spin it around the x-axis, and it's going to give us a 3D shape instead. So here's kind of what that graph looks like. Kind of like a parabola, but it's a little flatter here. And then we'll take this as x equals 1, and this is x equals 3. This is just an approximation so we can visualize this. So it'll be this region. It'll look something like this. And then what we're going to do is spin this around the x-axis. So this is the x-axis, and we're going to get these discs or circles that are traced out as we rotate this red line. And so if you can imagine, we have this red line, just imagine that coming down there at the bottom, here in the middle, out here, the top, and out here. So we're going to get this kind of expanding cone shape as we rotate this function around the x-axis. And so what we want to find is the volume. So normally when we integrate, we're just finding the area, and we do that by taking lots of small lengths here, multiplying them by a very tiny width, and then adding them up. And we're just going to do the same thing here, except instead of adding up small lengths, we're going to add up lots of small areas. So when we add up a lot of area, we're going to get a volume as our integral. A normal integral, we add up lots of small lengths or one-dimensional pieces, and our resulting integral is two-dimensional. But now when we want to find the volume, we're going to add up two-dimensional pieces, and that is going to give us a 3D representation. So what are our 2D slices going to be? Well, you can kind of see from this, as we rotate our function around the x-axis, it's going to trace out a circle. It's going to trace out a circular path, as shown by these green lines up here. So the areas that we're going to add up to find our volume are just going to be a lot of circles. So what is the area of a circle? Well, that's just pi r squared. Pi, of course, is just a constant. And then our radius, well, our radius is going to be just the value of our function. So let me just draw this one more time. Here's our function. Our radius is just going to be this length, which is f of x. And we're going to do that there. We're going to do it here. All over our function across our region of interest from 1 to 3. So hopefully that makes sense. So now let's find a function, let's find an expression for area. So our area is just going to be pi times r squared. Our radius is just our function, so that's going to be x to the fourth plus 1. And we're going to square that. And that is just going to give us pi times x to the fourth plus 1. So that's pretty much it. The difficult part of this is the conceptual understanding of what exactly is happening. So you just have to understand that we're adding up lots of circles, 2D pieces, in order to get a 3D integral out of our, troubles. So now, that was the hard part. Easy part is just doing the integral that you know and love. So here's our area. We're integrating our area on the interval from 1 to 3. And then we can go ahead and pull this pi out because it's a constant. Oops. We don't want to forget this dx here. Okay, so this should be the kind of integral that you guys are all familiar with. Let's write it down here one more time real quick. It's a simple power rule. We're going to end up with x to the fifth over 5 plus x evaluated from 1 to 3. And we go ahead and plug in 3. 3 to the 5th over 5 plus 3 minus 1 to the 5th over 5 plus 1. And then, of course, all of that is going to be multiplied by pi because we pulled that out. Let's just go ahead and simplify this. This is going to be, I trust you guys can work this out, 243 over 5 be 3 to the 5th plus 15 over 5, and then this is just a minus 6 over 5 over here, so minus 6 over 5, and then got to multiply all of this by pi, which gives us a final exact answer of 252 over 5 times pi, and that is going to be the volume of this expression once we revolve it around the x-axis.